Good morning, everyone. This is actually a very special episode because we have some people who are actually watching this live, and they promise to be quiet. So I know that's hard for Fenna, but she's trying. In this video, we're going to look at part 2 of paragraph 8.1, and in paragraph 8.1, we've already seen exponential growth. And to look at that again, we're looking at Os. And these are the people of the amount of people who live in Os over in between 2000 and 2004. And as you can see, over here the increase is 600, then 606. So the increase is increasing, which suggests that we probably have exponential growth. If you want to know the growth factor, you can divide these numbers. So if we want to calculate G, we're going to divide these two numbers. And G was a growth factor. And if we divide these two numbers, it's 1.01. And we can do that again, because maybe this is incorrect and maybe there is no exponential growth, but we can check that with these calculations. For the second 2 years, we're using 61206 over 6,600. And if you type that into your calculator, it's 1.01 as well. Do that for the third one. And you'll find the same answer again and again, which suggests that the growth factor is the same. Whenever the growth factor remains 1.01, that means we can say something about the growth in percentages. So this suggests a 1% growth per year. So if you want an exponential formula, the form n equals b times gt, we saw this in the last video as well, we can say that our starting amount in 2000 is 60,000 times g 1.01 to the power of t. And this formula works for Os after 2000. In a neighboring village of Os, Hayes, one of my favorite villages of course, we don't see growth, we see something that we will call exponential decay. So how does that work? If we look at these numbers in an absolute way, it decreases with 160. Over here, minus 157, minus 153, minus 151. This means that the decay is slowly becoming less and less. We can do the same thing that we did over here, but now our results will be somewhat similar but also somewhat different. You'll see. For the first two numbers, we are trying to calculate our growth factor. We took these two numbers and we divided them. We're going to do that again. If you divide these two numbers, you'll find 0.98. If your growth factor is below 1, it means it is decreasing. Let's try that again. So G is 7,683 over 7,840, which is 0.98 again. And you can keep checking that for yourself as well, that all of the other numbers also give you that same growth factor. And also for the last 2 years, it's also 0.98. So this doesn't suggest an exponential growth, but an exponential decay. And 0.98 basically means you're left with 98% after every single year, so minus 2% each year. And this is called exponential decay. Okay, we can also find an exponential formula for that. Our starting point is at 8,000. We're going to multiply that with the growth factor to the power of t. So right now we have two different formulas, a formula for Hayes and a formula for Olsen. Keep this in mind, because this is important. As long as g is above 1, there is exponential growth. And if g is between 0 and 1, then there is exponential. Okay. Are there any questions about this? Yes, Yuri. What if g is 1? If g is 1, well, something special is going on. Think about it. If you have, for example, 8,000 people, and you divide it with like a new amount, and the answer is 1. There's only one answer, 8,000. So if you go from 8,000 to 8,000, there's actually no change. Good question, Yuri, thank you. Are there any more questions? No? Good. Then hopefully this will help you in doing all of the other exercises of paragraph 8.1. Thank you and good luck.